Students, today we are starting a new chapter containing our trigonometric series, and the name of the chapter is heights and distances. As we know now about certain angles like sine theta, cos theta and tan theta, by use of these angles and theta measurements we will know that how do we find the heights and distances depending upon this line of sight and the angle of elevation and the angle of depression that is making that our eye makes with the horizontal axis when we see any object that is taller than us, or from from below the building, or something we observe from the elevation, that is from a mountain or certain kind of building elevation, when we observe something downwards. So when I am observing something downwards, that is angle of depression, not depression, like angle of downward angle. And when I am observing something above my horizon of line of sight of the eye, that is angle of elevation. Okay, like this one, like okay, to someone taller than you. So if you are observing a very tall guy, then you will say that that is angle of elevation is coming to play. So when your eye and the line of sight makes any angle theta that is above the horizon, then that will be termed as angle of elevation. So we have this 3-degree measurement. Most of the time you will be given this 3-degree value measurement, and whatever angle of elevation or depression you will form, you will always form a right angle triangle, okay, with the line of sight. So the trigonometric values of right angle triangle and their ratios can be well adjusted to find the angle. So if you are observing something from far away, that angle will be lower, okay. And same if you are standing just near to the building, then you have to just take your head just vertically above, just vertically above from your line of sight. Okay, so this angle is more than this angle. So suppose this is 30 degree, this will be 60 degree. Mainly we have to deal with three angles, that is 30 degree, 60 degree or 45 degree. 45 degree is the situation when length and breadth both are same. We will see it how. So we have this tan theta formula and sine theta formula and cos theta formula. So let's derive a Pythagoras theorem by using the ratios of these formulas. Okay, so we have tan 30 degree. The value of tan 30 degree is 1 by root 3, you know, but from the table 30 degree, 45 degree, 60 degree. So the value of tan 30 degree is 1 by root 3, and also this is perpendicular and this is base. So you put these values in a triangle, 1 and root 3. So and you square it, so you will get root 3 square plus 1 square is equal to 4 square, not 4 square, 4, which is equal to hypotenuse square. And you to take off this square, you root it down, so it will get 2. So you will get 2. And by getting these values and by getting these angles, you know, if one angle is 30 degree, another angle will be 60 degree, okay, and you have three values, 1, root 3, 2. So now you can get the value of sine 30, which is perpendicular by height, which is 1 by 2, and cos 60, root 3 by 2. You can also get sine, cos, tan, cot, sec, cosec, all the angles you can find out, okay, by using just one value. Okay, now when you get these values, you note it down the ratios. The ratios are 30 degree angle, 45 degree angle and 60 degree angle. So when you have a 30-degree angle, you will have the value opposite to 30 degree as 1. This side is 1. Just follow these two triangles very carefully. And when you have 60 degree here, you will have perpendicular as root 3. I have told you that perpendicular or base is in reference with the angle we take. Suppose you have 45 degree here. So according to this theta, the height is perpendicular is 1 here. And according to this theta, the height is 1. So whichever way you take, here both the cases are same, but here it is not same. Here it is not same. Here opposite to 30 degree it is 1, and opposite to 60 degree you have to root 3. So you have to remember these two triangles for our further observation on height and distance. So what we have in case of square, we know that the square, all the sides are equal. All the sides of a square are equal. So you have 1, 1. Obviously this will be root 2, and this angle will be 45 degree. Okay, because square diagonals cut it into two part, and the diagonal of a square and this all the angles, that is A, B, C, D, are 90 degree for a square, and all the sides are equal. So this is 1, this is 1, this will be always be root 2. Okay, so angle is 45 degree in case of square. Okay, we will take a question now. A boy standing at a horizontal plane finds a bird flying at an angle distance 100 meter at an angle of elevation of 30 degree. A girl standing at a roof of a 20 meter high building finds that the angle of elevation of the same to be around 45 degree. Both boy and girl are on the opposite side of a bird. Find the distance from girl to the bird. Find the distance from girl to bird. Okay, you have to find the distance. Okay, so we have given elevation of the building, and find the angle elevation from the same bird to the both the boy and girl are on the opposite side of the building. So one side there is a boy and another side there is a girl. The angle of elevations are given. Here the bird is flying from here. Okay, so angle of elevation is 30 degree given, and here it is 45 degree. Okay, now I have told you that, and what else is given? It is 100 meter. Okay, this description is pretty okay. So this height is 50 degree, 50 meter, and okay, this height is given, this is 100 meter. So from 30 degree angle of triangle, one triangle is of 30 degree. So if you look at this triangle, okay, the angle of elevation of bird from the boy's eye is making an 30 degree, and you know the ratio of the value of 30 degree is 1 by root 3. Okay, 30 degree is 1 by root 3. This 60 degree here, but we don't have to take it. So by taking the hypotenuse of it, you get 2 as a value of hypotenuse. So the hypotenuse value is 2, which is given 100 meter. Okay, so 1 meter is equal to 50 degree. Okay, so this entire length, which is 1, is 50 meter. 2 is 100 meter given, so 1 is 50 meter. Okay, so 1 is 50 meter. Now you have to take the another triangle, and this one here, you know that the value is 45 degree. So for the 45 degree value, we have 1 and 1, and that is root 2. Okay, and now you know that the standing at a roof of 20-meter high building, and this is 20 meter, so this part is 50 minus 30, this part is 50 minus 20, that is 30 meter. So this part angle value is 30 times of root 2, that is 30 root 2 meter. Okay, so the distance from the bird to the girl means you have to find the distance from the bird to the girl, this distance, that is 30 root 2. Okay, if this question is tough for you, we will come back to this question and let's proceed further. Okay, the answer is 30 root 2 meter. We are doing it by unitary method.